Okay, in this video I'm going to demonstrate a couple of approaches for carrying out the Breush-Pagan test in order to evaluate the assumption of homoskadasticity of errors that's associated with the linear regression. So the two approaches that I'm going to talk about, one involves an Excel calculator that I've created where basically you go through a series of steps that I've already laid out for you and then input information from those steps. And then at the end, there's actually the calculation of the Breusch-Pagan test. There's actually an original test and then a Kroneker's version of the test. The second option actually involves downloading a macro at this website right here. It's a really nice macro, and I have it installed on my computer, and I'll demonstrate its use as well. But we're going to start off by just using the Excel calculator with our data right here, and we're going to run our analysis and walk through the steps and input the information. So in this data set right here, we actually have 50 cases, and we're going to run a multiple regression with achieve as our dependent variable and then subject matter interest, mastery goals, and anxiety as predictor variables. So we're going to carry out our analysis. Step one, by the way, in our little calculators, run the regression and request unstandardized residuals. And then step two involves looking at the output in terms of the ANOVA summary table and typing in the sum of squares due to the regression and sum of squares due to the residual. So we're going to do all that. So we're going to go to regression linear. We're going to type in or put in achieve and then our three independent variables. We'll click on save and then request unstandardized residuals, click on continue, and then on OK. And so now we've run our basic regression analysis. If we look at our data set, you'll notice that at the end of it we have the unstandardized residuals from the model. And the residuals are nothing more than just the difference between the observed values on our dependent variable and the fitted values based on the model. So we'll look at our output now, and we have the ANOVA summary table with you'll notice the sum of squares due to the regression, sum of squares due to the residual. So we can either type that information in. I can actually double click on the table and copy and paste this information into my little ANOVA table here. So there you go. There's the sum of squares due to the residual. We technically don't need both of these, but the way I've set this up is to try to minimize the likelihood of making an error when it comes to putting the information in. So that's why you're actually putting in both of these when you actually only need one for the computations. All right, so the next step is step 3, which involves squaring the unstandardized residuals. So what I'm going to do now is I am going to go up here in SPSS to transform compute variable, and we're using the compute function to create the square of the standardized residuals. So I'm just going to create a target variable. We're just going to call it res2. I could call it anything, but it's just an arbitrary naming, so there you go. For the numeric expression, I'm just going to double click right here, so it says res_1. So that was what was generated in this column right here. And then 2 asterisks and then a 2 indicating that we're squaring the residuals. So next I'll click on OK. And now when we look at our SPSS data file, you can see that we have all positive values. So previously we had positive and negative values. Now we have all positive values. And so next what we'll do is when we're looking at our steps right here, we're going to carry out the auxiliary regression, regressing the squared residuals onto the predictors, and then we're going to look at the output from the ANOVA summary table, and we're going to put that information in. So we're going to go to Analyze, Regression, Linear, and take out the dependent variable, and we're going to put in the squared residuals variable here. Click on OK. And now we have our ANOVA summary table from that. So you can see all we need to do is just input this information. So I'm going to double click on this and put it in for the sum of squares regression, and double click here and put this in for the sum of squares due to the residual. Next, you'll see it says type in the number of predictors. We had 3 predictors in the model. Our sample size was 50. So essentially, the results of the original Breusch-Pagan test, this is our p-value right here, and essentially the way that you would interpret this is that, let's say you set alpha at 0.05. If the p-value is greater than the 0.05 alpha, then you would maintain the null hypothesis that of constant variance. In other words, our assumption of homoscedasticity of errors would be assumed to be met. If our p-value is less than 0.05, then we would reject the null hypothesis and infer that we have heteroscedastic errors. So this is the original Breusch-Pagan test. There's actually another version that is the Concurs version. I hope I'm saying that right. So this is a second option that we can use, and basically it's already computed for us, and we have a p-value for that as well. The reason why we might rely on the Concurs version is because the original Breusch-Pagan test is more affected by non-normality of the residuals. So this test appears to be more, I guess you could say, robust to non-normality of the residuals. So according to Wooldridge, this is probably the more preferred version of the Breusch-Pagan test. So at any rate, both of these have p-values that are greater than 0.05, suggesting that we have homoscedasticity of errors. So that's one option, is to use the little calculator that I've created. On the other hand, if you were to go to this website right here and download the macro, so this is the web address right here. If you download the macro, there's also a YouTube video demonstrating the use of the macro. So basically, I've already downloaded it, and if I go to Analyze Regression, and this is the macro right here that I've installed onto SPSS. I'm going to click on that, and I can put achieve in the dependent box or the outcome variable box, and my three predictors or independent variables in the explanatory variable box. It will actually carry out least squares with robust standard errors as well. So the default is the HC3 version. So I'm going to click on OK. And we're just mainly going to be looking at evaluating our assumptions. So you can see down below here we've got the Breusch-Pagan, the original version. There's a 3.54, and the significance level is 0.316. So if we go back and look at our output, you can see the 3.54 and 0.316 right here. If we want to look at the Concur version, which is in there, you can see that we have the test statistic of 5.674 and significance is 0.129. So if you look back at what we had computed, you can see right here that 5.764 and 0.129. So either way will work. That's essentially you can adopt either way. If you don't want to download the macro, then you can certainly download this calculator right here. I'm going to put it under the video description on my YouTube site, so you can download it straight away. Again, if you want to download the original or download the SPSS macro, you can go to this website right here and do that. So that pretty well concludes this demonstration.